Hello everyone, I am Dr. Tanmoy. I welcome you all in my channel TanmoyChem. Today's topic of discussion is one MCQ and the question is in front of you. I request everyone to attempt this question and write your answer in the comment box. Don't hesitate whether your answer will be right or wrong. Remember, self-evaluation is essential for improvement. So you should try. I believe you have tried, so let's start. Now, the question. Which of the following is the correct order of reactivity for aromatic electrophilic substitution? So here the question about aromatic electrophilic substitution is asked, and by the way there is no reaction given. So this question comes from basic concept. So from that point of view I can say you should know the very basic about aromatic electrophilic substitution. Now here it is electrophile. Actually electrophile is getting substituted in this aromatic nucleus. That's why it is called aromatic electrophilic substitution. So obviously from this you can say that electrophile is electron deficient species. So if it is electron deficient, it will preferentially react with electron rich species. This much is very easy to understand. Now let's go to electron donating or electron withdrawing group. So this group is actually both type. Now if you consider electron donating group, so electron donating group, for example you can say OMe. So this is electron donating group. Now this electron donating group will increase electron density in the ortho para position by resonance. Okay, so consequently I can say this ring is more electron rich, as this donating group donating electron density to the benzene nucleus. Now if this ring is more electron rich, then you can expect that reaction of electrophile will be easier. Why? Because electrophile is electron deficient and this is electron rich, so their reactivity will be better. Electron rich group can smoothly give its electron density to this electrophile and they can start the reaction. So two things we came to know here. One, that electron donating group make the reaction faster, and second point two is that the substitution happens on ortho and para position. So this is ortho and this is para, this two. But if you say electron withdrawing group, what happened? For example, I can say very famous electron withdrawing group, that is nitro. So what it does, it takes electron density from this benzene nucleus. So consequently this benzene nucleus is less electron rich. Now if it is less electron rich, its reactivity with electrophile becomes difficult. So it don't want to react more smoothly with electrophile. Not only that, if you look at the resonance, these ortho and para position get some amount of electron deficiency. I repeat the statement, ortho and para position get some amount of electron deficiency, and this deficiency is designated or indicated by this positive charge. So I can conclude that this NO2 group is actually, means this electron withdrawing group is actually deactivating. Okay, so here one thing they do, they deactivate, and if they deactivate, reaction became slower. Previously electron donating group, it was activating, so reaction rate was faster. So here it deactivated that ring, so that's why reaction rate is slower. Point number one. Next point is that here this meta position is relatively lesser electron deficient. Student, I repeat this statement, this meta position is relatively lesser electron deficient. I am not saying it is electron rich, I am saying it is relatively lesser electron deficient. So what is the benefit? That electrophile, although it is not that much interested to react, but still it will react in this any one of these two meta position. So it is actually meta directing. So this much part we understand. This knowledge will help us. Now if we look at the what is the order of electron richness, by the way benzene there is hydrogen, so no, it is neither electron donating nor electron withdrawing. So this methyl group is electron donating group, so it will increase that electron density on the ortho and para position, and it is activating. Now if you look at halogen, it is very interesting. It is actually electron withdrawing group, but it is orthopara orienting. Why? Because the lone pair on this chlorine, so one of these three lone pair can undergo resonance and increase the electron density in ortho and para position. That's true. However, this electron donation, I mean pulsar effect, is less dominant in case of this chlorine compared to its minus I. So it is actually strong electron withdrawing. Why? Because the higher electronegativity of halogens, here example is about chlorine. So this is minus I is more dominant. So that's why this chlorine overall act as electron withdrawing group. Since it's electron withdrawing group, so it deactivates. And obviously nitro group is also electron withdrawing group and it is a meta directing. So from this we can conclude the reactivity. So this is, you may consider positive, means activating. So which of the following is the correct order of reactivity? So it is positive, means higher reactive. It is 0, neither more neither less. In case of chlorine it is less, and in case of nitro it is more less. Okay, so you can expect that, okay, double. So from the, by the way, there is no quantitative analysis, so you can expect that this is more electronegative or actually more electron withdrawing compared to this one. So maximum reactive should be 2. Now let's focus where maximum reactive 2. So option C and option D. By the way, this is called process of elimination. If you follow, you can very easily remove all these junk options. So option A and option B gone. Now option 2 and option 3, next position goes to benzene 1. So 2, 1, 3. You got your answer. This is. Now actually you should know everything I just suggest, but remember, using this process of elimination, if you do not know the correct explanation for these also, you can get the right answer. So from there you can conclude that option C is the right answer, and you can see exactly the next one is 3. Why? Because here both plus R means donating, minus I is withdrawing, although minus I is dominant. And in case of nitro, both minus I and minus R both are dominating, and minus R effect is far more dominant or efficient compared to minus I. So this is very electron deficient ring. So this is the overall discussion. I believe this video may be useful. If you get this answer, think in this way. Plus, so it's a donating, plus I and hyperconjugation. So electron density maximum, this is 0. Okay, there is some amount of electron withdrawing, means minus I dominant, and it is very. And if you understand these two options properly, you'll have the right answer. So this is the overall discussion. I believe this video may be useful. If you really enjoy my content, please hit the like button and share this content with your friend and subscribe this channel. See you in my next video. Bye bye.